I welcome you to this lesson. I'm teacher Katimbo Richard, teaching Mathematics Primary 5. Remember, we started Term 3 work. If you are yet to get yourself a copy, please reach our school, train up a child, and get yourself a copy. That is for the two campuses, that is the main branch, that's Gorobi, then Najanankumbi, if you are near that way. In so doing, you will be able to follow us properly for these lessons. Today, I've come with finding the unknown in different polygons. Finding the unknown in different polygons. Still, we are looking at the length, mass, and capacity. We are still looking at the length, that is in metric units, that is centimeters, meters, kilometers, all that much. Now we are involving algebra. That's what's called integration of topics. So whenever you see finding the unknown, so it goes algebraic, has got that element of algebra. And when you watch this lesson successfully, you P5 member, you will be able to answer all the activities from page 26 all the way to 29 of our workbook. That is P5 term 3. I urge you follow strictly so that you can answer all those activities for the same pages of 26 all the way to 28, actually 29 of our workbook. Now, first example reads, use the figure below to answer the questions that follow. Look at this figure. You usually call a combined figure, but I actually term it as a hexagon. For it has got 6 sides. Let's count together. 1, 2, 3, 4, 5, 6. Any 6-sided polygon is called a hexagon. So, although that is irregular, not all sides are equal. So, let's find the unknowns. There are two, x and y. So, while finding the unknown here, we must have a particular knowledge about this. So, we must have some knowledge about this. So, we've got two long sides. This is long and this is long. If at all, one, if not both, is not known, that is, it has an unknown, it's got by addition because it is a long one. So this is long, this is long, long. Then the short ones are 4. These other 4 sides among the 6 are short. Again, what you have to bear in mind is the word horizontal and vertical. A vertical line is that line going from north to south. That is from up as go downwards. So north to south, south towards the north. That is a vertical line. When I say draw a vertical line, you draw a north-south line. Then when I say horizontal, east-west line. So I've got 3 horizontals and 3 verticals. 3 horizontals and 3 verticals. Let's look at the vertical. This is a vertical line. This is a vertical side. This is also a vertical side. So 3 verticals. Only that we've got 1 that's long, the other 2 are short. This is called a long vertical, short vertical. So long vertical is formed by addition of the verticals, whereas a short vertical like y here is formed by subtraction of the verticals. Now let us see horizontals. This is horizontal line, horizontal side. So we have the long horizontal, which will be formed by addition of these other 2 horizontals. So any horizontal, we use the horizontals to find it. Any vertical that's missing, use the verticals. If it is long, it's formed by addition. If it is short, it's formed by subtraction. Only that is the knowledge you must have to answer this. And without that knowledge, you cannot answer any question concerning this very number. For example, let's say find the value of x. I say x is a long horizontal line and add the horizontals, these short ones, to find the long one. So it is 9 decimeters plus 4 decimeters. So we go x equals 9 decimeters plus 4 decimeters, or x value then is 13 decimeters. So this is 13 now, and then you find the value of y as required in part B. Find the value of y. Y is written along a short vertical side. Being short, then it's going to be got by subtraction of the other two verticals. So the longer vertical is 10 decimeters, then the shorter is 5 decimeters. So there are the two you are going to start to find this y. Why? Because it is a short vertical. Anything short here is followed by subtraction. You shorten, you lessen, you take away to have a lessened value still. So you get y equals 10 decimeters minus 5 decimeters to get the 5 decimeter length there. So that's how we find the unknowns for this hexagon, the one we call a combined figure. And now we go to example number 2. Find the value of the unknown, which unknown is x. Find the value of x. They have drawn a standing rectangle. This shape is a 4-sided polygon called a quadrilateral with 2 opposite sides equal. So we call this one length, this is also length. Those 2 lengths are equal. This is width, this is also width. The 2 widths are equal. That's why anyway, we have got these 2 sides against 2. These 2 are equal on their own, and this is side 1 against 1. These 2 are equal. So length got length, and then width is equal to width. It's upon you to look at what's available to you so that you equate to find the unknown. So now the 2 lengths are given. That's why you say length is equal to length. That's the concept here. The 2 lengths of any rectangular surface are equal. You say length is equal to length because they are available to us. Now, if the examiner had availed us the width instead of the length, we would say width is equal to width. But now, none of the width is here. So we use the length to find the unknown by equating. That is length equal to length. So we start working out. So we say length is equal to length. That is 2x plus 4 centimeters is equal to 3x minus 3 centimeters. You see centimeters are this way, and they are enclosed in brackets. So that they are outside the brackets. If the centimeters are outside, we start by eliminating them. Divide either side by centimeters. So it comes to centimeter. Then remaining 2x plus 4 equals 3x minus 3. And now we move. Now we go. If it is a plus 4 in algebra, we introduce a minus 4 either side so that we collect like terms properly. So we go 2x plus 4 minus 4 equals 3x minus 3, then minus 4 because we did subtract this side. Where 4 minus 4 is a 0, so remaining 2x this side. And now here I've got 3x. Then negative 3 take away 4. So from negative 3 on the number line, go back 4 other steps. Where do you stop? From negative 3, count back towards the negatives. Count negative 1, negative 2, negative 3, negative 4. You definitely stop at negative 7. So negative 3 take away 4. You get a negative 7. So I've got 2x equals 3x minus 7. Then this is 3x and 2x are scattered, yet they look alike. They are the ones we call like terms. And again, identify them as either positive or negative integers. So this is a positive integer and this is a positive integer as well. So in algebra, when you cross the equal sign, the sign changes. So the one has been a positive becomes a negative. So we are going to eliminate the 3x this side by subtracting, by making it a negative either side. So we go 2x this side, take away 3x equals, this is 3x, take away 3x, then minus 7. So that 3x minus 3x is no longer this side, you have a 0 here. So this side you remain with the negative 7. Then 2 minus 3 is a negative 1. So we are not allowed to write negative 1x. I said we are not allowed to write negative 1x. You instead say negative x. Negative x is equal to negative 7. But remember, they told you, or you were asked to find the value of x, which x must not bear a negative. But this one has got a negative. So a negative 1 must leave. Remember, 2 minus 3 is a negative 1. That's why we divide both sides by negative 1. So that is negative x divided by negative 1 equals negative 7 divided by negative 1. Where negative divided by negative, you get a positive. So either side shall have a negative, a positive. So you say x equal to 7. Positive x equal to positive 7. So x is equal to 7. And that's all. You have used the rectangular properties to find the unknown. For they have given us the two lengths and we know they are equal. You start by stating length equal to length and then do like teacher has explained now. In that way, you will then be able to answer anything connected to that kind of concept. As we look at example number 3. Example number 3 reads, find the value of P. Find the value of P. Wherever you have made the shape, please identify that shape in among the polygons. When you look at this shape, it has got all sides equal, then it is a square. A square is a 4-sided polygon with all sides equal. If all sides are equal, then indeed 4p is equal to 8 centimeters. So do we state 4p equals 8 centimeters because any side of the square is equal to the other side. So you say side is equal to side, 4p equals 8 centimeters. Now what the value of p? We eliminate 4 from this side by dividing the other side by 4. That is 4p divided by 4 equals 8 centimeters divided by 4. Where 4 divided by 4 is 1, then 4p divided by 4 you get p, and then 4 divided by 4 is 1, then 8 divided by 4 you get 2, and this centimeter. So value of p in that regard is 2 centimeters. So that's how we answer that question, because we identified this to be a square. So then number 4, look at the shape involved, identified among the polygons. So this is a triangle, a 3-angled polygon. So tri means 3, then angle. So 3-angled polygon and has got 3 sides as well. So it's the 3-sided polygon, which is a triangle, And then among the triangles, we have got 3 categories. We have got a scalene triangle, which has got no side equal to the other. So a triangle without any side equal to the other is called a scalene triangle. And then a triangle with the 2 opposite sides equal, like this one. What shows they are equal? These sides you see here. Only 2 of the sides are equal. So this is called an isosceles triangle. The spelling is this one isosceles. If you are asked to identify the type of triangle this one is, you say isosceles. I-S-O-S-C-E-L-O-E-S, the word isosceles. That is isosceles, like you see there. There is letter S here. So that is I-S-O-S-C-E. Master, please mark this letter S, S-C-E-L-O-E-S. So the word is isosceles. What's an isosceles triangle? Isosceles triangle is that triangle that's got 2 of the sides equal. What shows they are equal? These sides you see here, shaped like 11. They mean this side is equal to the other, but this one is different. Whereas the other one has got every side equal to the other, meaning all sides equal. It's called an equilateral triangle. It's called an equilateral triangle. Equilateral. E-Q-U-I. Equi. Then lateral, like lateral line for your fish. So that is equilateral triangle. So we are talking about the isosceles triangle. The one has got 2 of the sides equal. And now, since it has got 2 of the sides equal, we name the other side that's different from the other 2 the base. We call this a base. And now, what about the base? Base angles of an isosceles triangle are equal. Base angles of an isosceles triangle are equal. If this is termed as the base, this is one of the angles at the base. This is the second angle at the base. So these two angles at the base given an isosceles triangle, please, are equal. If it's not isosceles, never should you bring that. And we call a base when it's different from any of the other two sides. So this different sides called a base. What about it? The base angles of an isosceles triangle are equal. If that is true, then form an equation of algebra, then find the unknown as required by this very examiner. So I've got y plus 35 degrees equals 83 degrees. Y base angles of an isosceles triangle are equal. Without that knowledge, you will not be able to answer this question. So we form this equation, like I said, y plus 35 degrees equals 83 degrees, y base angles, this side is angles. So base angles of an isosceles triangle are equal. That's why I've equated them. And now we work out this algebra, which we worked out right from our P.5. So we say y plus 35 degrees minus 35 degrees equals 83 degrees minus 35 degrees. Now, to be accurate, align your working vertically or downwards. Right? 83 on top of 35 and then subtract in accordance with their place values. So 3 minus 5, you can able tell that's only possible after borrowing. You know why I say impossible? It's not even normal. So we usually say impossible. So it's not impossible. Anything impossible then cannot be found the answer for. So you cannot find the answer for something impossible. So we say possible after borrowing. So the neighbor lends us 1, which is equivalent to 10. Why? This is base 10. So we borrow the base as usual. So we borrow the base. So 8 lends us 1 and it remains 7 and then the borrowed 1 is equivalent to 10, which 10 when added to 3 gets 13. Now 13 minus 5 you get 8. That is if I'm accurate, and I am. Then 7 minus 3 you get 4. Thereby getting 48 degrees after subtraction. So you get y plus nothing here. 35 minus 35 is a nothing, which is equal to 48 degrees. So the value of y is 48 degrees. All in all, you must know the angle property here about this kind of triangle, which is isosceles. Base angles of an isosceles triangle are equal. So this angle is equal to that angle because both are aligned at the base. So we look at the last example for this particular lesson, which tells us to find the value of y in this shape. Find this unknown y in this shape. Again, the shape is like number 2. On the other hand, the standing rectangle, this is a sitting like the board is. So the board is sitting properly. So the board is rectangular, where the length is equal to length. This length, you see, is equal to this upper one. Likewise, the width is equal to this width. You see this side. If so, now let's see which two are available to us, and then we equate. The length is here as well as the length here. Oh, since we know length equal to length, so do we say length equal to length. Here we cannot find y using the width, since we don't have the width the other side. So you cannot formulate yours. I don't have that option whatsoever. You cannot set your own question, however clever it may be. Please don't set your own question. Please do follow the question dictated by that examiner. So examiner has dictated the two lengths. These two lengths are equal. So let's say length is equal to length. That's the concept, by the way. So you must show length equal to length so that you can ably write 2y minus 3 centimeters is equal to this down one, y plus 3 centimeters. So then I told you when centimeters are outside the brackets, you eliminate them through division of either side. So divide either side by centimeters Then cancel by centimeter by centimeter. By centimeter by centimeter, thereby remaining with 2y minus 3 is equal to this remaining y plus 3. Then start solving algebra. Opposite of minus is plus. Algebra is something, yes, that's something to do with an opposite style. So do the opposite of what is brought. So opposite of minus 3 is a plus 3. So do add 3 to the other side to eliminate a negative 3. Bring a plus 3. So I've got 2y minus 3 plus 3 is equal to y plus 3 plus 3. Y plus 3 plus 3. So minus 3 plus 3 is the same as 3 minus 3. That's why I interchanged it by virtue of body mass. So go 2y plus 3 minus 3 is equal to y plus the sum here, which is the 6. So 3 minus 3 is a 0, so the value of this 3 has gone the other side. The side that is now a 6 the other side. So we have 2y equals y plus 6. Scatter these two y's, so that's 2y and y. So let them be collected together. Gather them. So please, they go to the opposite of this positive y. An integer without a sign is a positive integer, so you take the other y, or this y on the other side, through creating it as a negative. So creation of a negative onto it. So we subtract subtract y from either side. We say 2y minus y equals y minus y plus 6. I said 2y minus y equals y minus y plus 6, where 2y minus a single y remains a single y, where we don't need to write a 1 against an unknown. Never say 1y, just say y. And now y minus y is a 0, so the value this side is only 6, so y is equal to 6. In that way, you will be able to answer all those activities. It can go an extra mile into asking you for the actual length and width. So they can go an extra mile into asking you for the actual length and width. These are not actuals. So long as they have got any letter of alphabet, they are not actual. So you go actual length, replace, or simply substitute y with 6. So you say 6 plus 3 is the actual length. So the actual length is actually 9 centimeters. Then y centimeters, where y is 6 is the width. So 6 centimeters the width. So the actual length is 9 centimeters and the actual width is 6 centimeters. Then later they'll ask you to find the area of the shape here. So you say area is called length and width. Area equals 9 centimeters. You know where 9 has come from 6 plus 3. So that is 9 centimeters times 60 centimeters. And get your answer. If you now multiply, you'll get 54 centimeters squared. Then later again they'll ask you for perimeter, which no distance around any given object. So go, this is a rectangle. Perimeter is called length plus width plus length plus width. Use the actuals, that is 9 centimeters plus 6 centimeters plus 9 centimeters plus 6 centimeters. In so doing, you have answered all the questions that can ably be set on that particular number. In short, that is about finding unknown in different polygons, that is in our P5. This is term 3, measures of length, which we have analyzed today. Therefore, for more information about the same, that is, if you need any clarity, please don't hesitate reaching this very teacher, Katimbo Richard, on these two numbers you see here, 0776 251655. Alternatively, use 07572 33066. Otherwise, that is the end of the lesson. Please stay safe. We meet in the next episode.